Hi everyone, in today's lesson we're going to review exact values. Before we can get into a couple of problems, we need to review a couple of definitions. First, a reference angle is the angle formed by the terminal side of the angle and the x-axis. So I'm going to just highlight the terminal side in green, and then I'm going to highlight the x-axis in yellow, and then I'm going to do an example in each of the four quadrants so that you know how to find the reference angle in each. So in quadrant one, here's an example right here of 40 degrees. So let's highlight the terminal side, or where the angle ends, and the x-axis. So the terminal side of the angle and the x-axis happen to overlap right here where the original angle is. So what that means is angles in quadrant one are actually their own reference angles. All right, let's look at example two. So for quadrant two, here is the terminal side of the angle, or where the angle ends, and here is the x-axis. So our reference angle is actually going to be this angle in here. So if we're starting here, from here to here is 140. If we continue this half moon and go all the way to the end of the x-axis, we'll be at 180 degrees. So you want to ask yourself, 140 plus what angle gives me 180? And you should be thinking 40 degrees. How you can get that is take 180 and subtract the given angle, which is 140. And that will give you your reference angle of 40 degrees. So in quadrant two, to find a reference angle, it's just 180 minus the angle. How about an example in quadrant three? So here's the terminal side of the angle. Here's the x-axis. So the angle in there, the reference angle, would be here. This one's a little bit harder to see. So starting the angle here, and we go around all the way to here, is 200. So if I want to find this little piece, all I actually have to do is subtract 180. So think of it this way. If you've already started from here to here, you've got 180, that's your half moon. How many more degrees do I need to go to get to 200, right? So you have to think about subtracting from 180 because this half moon is 180. So you have 200, all of this, take away the blue, you have the red. So if you're in quadrant three, you take the angle and subtract 180. So the angle here is 200 minus 180 gives us 20 degrees. So this angle in here is my reference angle. And then last but not least is if we're in quadrant four. So again, we have to highlight the terminal side of the angle and the x-axis. And the angle between that is going to be your reference angle. So right in here is your reference angle. So if you think about it, you've already have from here to here is 320, and I want to know how many more degrees I'm going to have to go to complete that circle, which would be 360. So 320 plus 40 is 360. But what we could do is simply subtract from 360. So the angle in quadrant four is 360 minus the angle. So 360 minus 320 does in fact give you 40. So this was just a quick review as to where they come from, but theoretically all you need to know is how to use them, and here are the four rules. Okay, so let's move on to what a coterminal angle is. So a coterminal angle is an angle that terminates in the same spot as another angle. And the way that we find it is by adding or subtracting any multiple of 360 degrees. So an example would be, let's just say I wanted to add 360 to this one. 40 plus 360 would actually be 400 degrees. Now, 400 degrees would be going around the circle once and then a little bit more, which exactly is 40 degrees more. Therefore, that's 400 degrees, which will end in the same spot as 40 degrees. Now, I could theoretically subtract 360 if I wanted to. So let's just say I took 140 minus 360. That would give me negative 220. So what I could do is say negative 220, which would start here, go down and around. This negative 220 would in fact end in the same spot here as 140. Now, if I wanted to, I could say take 200 and add 360 twice. So if I did that, I would get 920. And if I started here, I would go one circle, two circles, and then 200 more, and I'd be at 900. So it doesn't matter what multiple you add or subtract, it's always going to wind up in the same spot. So I'm not going to do an example with quadrant 4, but that's the general gist of coterminal angles. So the last thing we just need to talk about is this all students take calc, which should be familiar from Algebra 2 or pre-calc. So let's just draw a nice big XY axis, and let's put an A, S, T, C. A stands for all trig functions are positive here. S stands for sine, that sine is only positive here. T stands for tangent, that tangent is only positive here. And C stands for cosine, is only positive here. So the way this works is, let's just say we're in quadrant 3. So for quadrant 3, tangent is the only thing that's positive. So let's just say I'm talking about sine in quadrant 3, then sine would be negative, right? And we'll talk about that a little later on. But there's also one other thing. Their reciprocal pairs are also positive. So remember, sine and cosecant are reciprocal pairs. Cosine and secant are reciprocal pairs. And tangent and cotangent are reciprocal pairs. So since reciprocal only means 1 over, we don't actually change the sign, so that includes that it's positive in those quadrants. So if we wanted to write it out, in quadrant 1, all trig functions are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, tangent and cotangent are positive. And in quadrant 4, cosine and secant are positive. All right, so let's put this all to work in an example. So example number 1 says cosine of 240. So first things first, we need to convert the angle to degree that's between 0 and 360. If it's not, we might need to use coterminal angles. So 240 is definitely between 0 and 360. So step 1 is good. Step 2, I like to use quarters or forsotas. So Q stands for quadrant, R stands for reference angle, F stands for the given function, and S stands for sine, whether it's positive or negative. So you can draw a picture if you'd like. So 240 degrees would probably be an angle that would end in quadrant 3 somewhere. So 240, right? Then we have all students take calc. I always like to write that, that helps. So we know that Q, we're in quadrant 3. Well, how do you find a reference angle? That's what R stands for, a reference angle for quadrant 3. So if you look at the front page, a reference angle is the angle 240 minus 180. So in this case, it would be 60 degrees. F stands for function. So the given function that we have here is cosine. So cosine. And S stands for sine, S-I-G-N, whether I'm positive or negative. Well, in quadrant 4, the only thing that's, 3, the only thing that's positive is tangent. So since we're dealing with cosine, we know that cosine must be negative. So negative. And what we do is we read it from the bottom up. So we have negative cosine of 60 degrees. So technically that's not the answer. The last step is to use the exact value chart to finalize it. So the exact value chart is something that we wrote down the other day. So what I want you to do is go to that chart and look at cosine of 60. So the exact value will be found by taking negative cosine of 60 and putting it with the chart. So you should know that cosine of 60 is 1/2. So negative 1/2 is your final answer. All right, I'm going to do the second one with you, and then the third one, you're on your own. So first things first, with the 17 pi over 6, we cannot do this until the angle is in degree. So 17 pi over 6, to change from radian to degree, we have to multiply by 180 over pi. Pi's will cancel. And we're going to do 17 over 6 times 180 in our calculators, and that'll give us our degree. So take a minute, pause the video, and do so, and hit resume when you're ready. Okay, so you should have gotten 510. So what you were really asking to do is find cotangent of 510. But 510 is a problem. 510 is not an angle between 0 and 360. So we have to use the concept of coterminal angles. So let's try subtracting 360 one time and see what happens. So if we do 510 minus 360, we get 150. So the goal is to make the angle between 0 and 360. So is this 150 between that 0 and 360? Absolutely. So we actually can change the problem now to say, let's find cotangent of 150. So this is the problem that we actually want to solve. So we're going to go over here. We're going to do our Q, our R, our F, our S. I'm going to draw a quick picture. 150 is now in quadrant 2. And I'm going to do my all students take calc again. And since we are in quadrant 2, for Q, we can put 2. Reference angle now is a different rule, so we can look at the front. For quadrant 2, it's 180 minus 150, which is in fact 30. For our function that we're dealing with cotangent, so we can go ahead and write cotangent. And the sign S for quadrant 2, sine S is the only thing that's positive. Therefore, cotangent will be negative. So if we read it from the bottom up, it's negative cotangent of 30. So what we need to do is find our exact value of that. So negative cotangent of 30. Well, if we look at our exact value chart that we drew the other day, cotangent is not on it, but we know tangent is. So what we're going to do is we're going to look at tangent of 30, and then we're going to flip it. So look at your chart for tangent of 30, and then hit resume when you're ready for the answer. All right, so for 30, you should have gotten rad 3 over 3. So if I want to find cotangent of 30, I just have to flip this. So it's going to be 3 over rad 3. And don't forget the negative, because it's negative cotangent of 30. Now, bells and whistles should be going off in your heads, because we're not allowed to have a negative in the bottom of a fraction. So the way that we get out of that is by multiplying the top and bottom by the radical in the denominator. So when we multiply the tops together and then we multiply the bottoms together, we're going to get negative 3 radical 3 over radical 9. Why? Because rad 3 times rad 3 is rad 9. So then it's negative 3 rad 3 over 3, because the square root of 9 is 3. These outside 3's can cancel, so we get negative radical 3. And that is our final answer. So I'd like you guys to try this last one on your own and hit resume when you're ready for the answer. All right, here's the answer. So take a look at it and let me know if you have any questions, and we can go over it in class tomorrow. All right, have a good night.